I am Amy, and I'm here to guide you through the biological and geomorphological field indicators that are used by the Northeast and the Southeast SDAMs. As we mentioned before, there are actually 10 total indicators. There are, the Northeast uses 8 of these, and the Southeast uses 7, and 5 overlap. And we're going to start out with the benthic macroinvertebrate or BMI score that is used in both regions. And then the proof is going to be if I can move this. Oh, yay. Okay. So the BMI score is a score between 0 and 3 that is based on a combination of abundance and richness of all aquatic benthic macroinvertebrates, which I'm going to term BMI to save myself. And this is not just insects. The level ID for the richness measure is dependent on the taxon. Family level for aquatic insects and mollusks, order level for crustaceans and mites, and then class or phylum level for all other non-insects. And for these methods, we do not differentiate between live organisms and then non-living material like, cases or shed skins. We're going to count all of these. However, we are going to ignore terrestrial life stages. So if the only thing you see is a terrestrial adult dragonfly flying around, that does not count for this. To collect BMI, you're going to complete a 15-minute search in at least 6 locations that represent all present habitat types using appropriate methods, like riffles, pools, leaf packs, undercut banks, all habitat that you can find that's present, different types anyway. The sorting and ID time is not counted in that 15 minutes. That's something you have to be doing afterwards and allotting time for. Beginners might be able to use a hand lens or a field microscope, but more experienced assessors might be able to ID with an unaided eye. In riffles, you would be using a D-frame kick net. You'd be starting at the downstream and working upstream. And you would take the kick net and you'd place it perpendicular to the flow, keeping the bottom flush with the stream bed. And then just make sure the net is fully extended and not obstructed by anything. And then you'd be stirring up the substrate immediately upstream with your hand or someone else's foot or your own foot, though, however that would work. And then you would empty the contents from the net into a white sorting tray with stream water. I know Rafi just said something. Oh, he answered it, though. Columbola? No, I don't think we ignore anything, really, including mosquitoes, and I'll get into that. Okay, so that's riffles. In locations with still water, like a pool, you place the net in the water, you kick up the substrate, and then move the net around to try to get what was then suspended in the water column. In woody jams, root mats, and undercut banks, you would jab underneath, generally with a D-frame net. That's a big woody jam or a beater dam. And you pick up and examine large cobbles or other substrates. You might be able to find heptagenated mayflies and other things clinging to the underside of the rocks or caddis-like casings. BMI and evidence of BMI can also be found in partially dry and dry streams in these areas. Look for areas where water may have persisted and focus on remaining wetted habitats. Where water might have persisted longer but is currently dry, turn over cobbles and boulders in areas where the water was likely there longer. You can look at the streamside vegetation or large boulders for shed skins. Also works. Okay, so I mentioned that, our richness depends on the level of ID depends on what taxon we're talking about. And technically, identification of taxa is not required for this indicator. You may have 2 kinds of mayflies and you can tell that they're different, or different families, but you can't necessarily tell what family it is. That is okay. But if you are going to be identifying things and you are going to rely on field identification, you can either do field or lab processing. In the field, you're definitely going to want to have somebody who has been adequately trained in this. You want to maybe retain voucher specimens to confirm identifications. And then, as I mentioned previously, use hand lenses or field scope if available. If lab processing may be a better option, field crews may not have the necessary expertise for identification. You'd have a higher confidence in identification generally. Samples may be reevaluated by experts, and it can save time in the field. So for field sorting and identification, remove and ID any suspected BMI up to 5 taxa, and you'll see why I say that later. And then keep an abundance tally. For the Northeast, you can stop counting at 11 because the Northeast it only uses this indicator for BMI, but in the Southeast, there's another indicator we're going to use, and it's going to require you to keep a tally of more than 11. And you'll see that in the next indicator. Featherweight, forceps, and eyedroppers can help with real small stuff. White back tray makes it easier to see things moving around. Sometimes you move the tray around to be able to see stuff better, or they'll start moving. Make sure you look at the net for anything clinging to it. And then it's recommended you collect specimens to confirm identifications, but again, that's not required. There's kind of two different book types. You have your keys, your lab keys, which are real big and heavy. Not always, but like the Merit tends to be. And then you have your field guides. And there are some out there, like the Vochel's Guide to Common Freshwater Invertebrates North America, and then the Thorpe and Rogers Field Guide. And then I'm sure there are other ones out there, but you may not want to bring books. Other resources for BMI identification, a big one is the Atlas of Common Freshwater Macroinvertebrates of Eastern North America. This is macroinvertebrates.org, which is an invaluable resource, and it also has a phone app now called Pocket Macros, which is pretty neat. And then the USGS has the North American Aquatic Macroinvertebrate Digital Reference Collection. The current focus is on states west of the Mississippi, and some taxa only have adult photos, and for certain things, that's not really helpful when the adults are terrestrial. So in the next few slides, we're going to do some real high-level ID. And so our goal today was to provide you with an overview of BMI that was commonly encountered during field data collection for the SDAM sampling effort. It is not going to provide you with enough training to distinguish all BMI taxa in the field, but we figured we could start out with some of the stuff that's commonly found. This is a screenshot from Macroinvertebrates. This is an order and class level key that they have. It might be a good starting point if you're trying to figure out whether something is a mayfly or stonefly. And there are many BMI keys for field use, something that might fit on one page. This one is a mix of family and order level for insects and mollusks, and order and class level for other non-insects. And I have used this one in the past. What I've done, this is put out by the University of Wisconsin Extension. And then the next few slides, we're going to get more into like families and orders, and I may murder some of these family names, but I'm going to try not to. So we're going to start with the mayflies of order Ephemeroptera. Mayflies generally have 3 tails or cerci, which you can kind of see here. And they have gills on the abdomen. One of the most common of all taxa that was collected in the field were the heptagenaid or flat-headed mayflies that are depicted on the top left. These were usually followed pretty closely, at least as far as mayflies go, with the betids and the leptophlebid mayflies. And then other ones we saw were the spiny crawler mayflies and then the comb-mouthed minnow mayflies. And then we have stoneflies, the order Plecoptera. These have two tails or cerci and gills on the thorax for the most part. The pearlid or the capnid stoneflies or the most commonly collected stoneflies depending on the season. The captain stoneflies were most common and abundant during sampling events in the winter and early spring, as their name might suggest, small winter stoneflies. Other ones that were found, the Lutridae are pretty common, the Nemoridae, and then the striped tails, preludids. All right, so caddisflies of order Trichoptera. These often build cases, and they have gills on the ventral side of their abdomen. So, sort of, mayflies have it on the top side, the caddisflies have it on the bottom side, with the prolegs at the end of the abdomen instead of those long cerci or tails. Families collected included both free living and net building caddisflies, as well as those that build cases. Which in those cases you may also find in dry channels. The hydrocycid caddisflies were the most common caddisfly family collected and one of the most common abundant families overall. Two predominant case-making families were the Limnophilidae and the Lepidostomatidae. Oh, I think I said that right. With some of the other ones here, like the Phyllopotammidae, and then the trumpet net caddisflies making their little nets, or the free living ones, the Rhyocophilidae here. So moving on to beetles. So the order Coleoptera can include both aquatic larvae and adults, whereas the first three slides were dealing with aquatic larvae only. The most common beetles encountered were the Dyticidae, where both the adults and the larvae are aquatic. And the same goes for all the rest shown here, the Elmidae, the Hydrophilidae, except the Sphenidae, or the water pennies in the top right, where only the larvae of those are aquatic. All right, moving on to the odonates and the Megaloptera. So the odonates are the dragon and the damselflies. One of the more commonly found ones were the clubtail and spiketail dragonflies, and then the broadwing and narrow-wing damselflies. And then the Megaloptera, the real scary looking Dobson flies. Those are always fun to find. And then the alder flies is shown there. So, as probably many of you would expect, the chironomid midge larvae were the most common and abundant taxa for all sampling periods. The larvae can be various shades of yellow, green, and red. They have no visible legs, just some thoracic and anal prolegs. And those are just the ones where, at least the ones I find a lot, the little red ones, people call bloodworms. It's not really blood. And then, so meniscus midges here, the Dixidae, were also found pretty commonly. They also have no legs, but have the addition of some like flat lobes fringed with hair. You can almost see at the bottom here on that last abdominal segment. And then, of course, you have your black flies, and mosquitoes are included here as they're included as as BMI. The Western Mountains method actually excludes mosquitoes in their sort of similar indicator, but here we include them. And then you have, and then you have chipulids, the crane flies, and then so some Hemiiptera. These are all adults that you're going to find, the aquatic adults. The the water skaters, the water striders, the back swimmers. Those are found. And then we have some common mollusk families and crustacean orders. So mollusks are identified to family level, or they count as family level for the richness. And then crustaceans are actually order level only. And here, the Asian clam, it's pretty widespread. The physid snails, the ram-sworded snails, less so, but they were found. And of course, you have your crayfish, and then your amphipods and your isopods. The crustaceans also include the water mites, but I don't have a picture of those. And then other invertebrates, these only need to be identified to class or phylum. These are usually like your annelids, and then the platyhelminthes. So here we have, it's really hard. I can't really read it. Anyway, you have 0 to 3. 0 is absent. Total abundance of benthic macroinvertebrates is 0. Weak is a 1. The total abundance is 1 to 3 in BMI. For a moderate or level 2 is total abundance must be greater or equal to 4. And then when you get down to the strong is where the richness comes in. So if you have a strong score of 3, your total abundance is greater than or equal to 10, and richness is greater than or equal to 3, or richness is greater than or equal to 5. And in some of our other SDAMs, evidence of the mayfly, stonefly, and caddisfly, which is EPT, is used for the beta SDAM. The arid west, that's order level ID. And then for the Great Plains, they use family level ID for the EPT. And then the arid west and the western mountains also rely on kind of all aquatic invertebrates found to inform the stream flow determination, whereas in Great Plains, we're only using the EPT. So, and then here again, where that 5, as long as if you've got 5 taxa, then you're automatically a 3. So you don't have to go any more than that.